Okay, hi guys, Miss Burns here, and we're going to take a look at section 3.1, which is on quadratic functions. We did a little bit in chapter 2 with quadratic functions. We talked about parabolas, and we're going to get a little more in depth with that. So at the beginning of the guided notes, you'll see that there's a little preview here. It says, when products are sold with variable discounts or with prices affected by supply and demand, revenue functions for these products may be nonlinear. Suppose the monthly revenue in dollars for the sale of X televisions is given by this function. So if you're a business major, you'll probably see this again in some of your business courses, but the revenue function is given by this expression, negative 0.1x squared plus 600x, where x, remember, is the number of televisions that they sell. So this is an example of a quadratic function. We've talked about them, like I said, a little bit in the last chapter. Anytime you had something squared, that was an indication that your parent graph was the quadratic function. They're usually written in this form, ax squared plus bx plus c. Back in chapter 1, we talked about solving quadratic equations, and that's what we're going to be looking at again a little bit in this section. The graph of this, remember, is called a parabola. So if the equation, the a value, the leading coefficient there in front of the x squared, is positive, that makes the graph open up. The point at the bottom, if it opens up, the lowest point on the graph, is called the vertex. If the a value in the front, that leading coefficient, is negative, that makes the graph open down. And in that case, that maximum point is called your vertex. So you either have a relative minimum in the graph or a relative maximum in the graph, depending on which way the parabola opens. The graph of the function, it's a little hard to see. It's kind of a dark image, but the graph of the function, the revenue function we were just talking about, is given here. Notice that it opens down, and that should make sense because the a value is negative 0.1. That's the coefficient on the x squared. The vertex there is at the top, so that's a maximum. The line that cuts through the parabola right through the vertex and cuts it in half is called the axis of symmetry. So the question says in the above graph, how many TVs must be sold for the company to produce a maximum profit? They're essentially asking you for the maximum, which is the vertex. So that point right there, it looks like it's at 3,000 televisions. They'll make a maximum revenue. And actually, I used the wrong word here. I said profit. I should have said revenue. But the maximum revenue, it looks like, is about $900,000. So the vertex, the coordinates for it are 3,000 and 900,000. And then, so the question said, how many TVs must be sold to get that maximum profit? That would be the X value of 3,000 TVs. And then the maximum revenue, not profit, would have been the $900,000. So the equation of a quadratic is often written in that form we just talked about, the ax squared plus bx plus c. But another way it could be written is like this, a times a minus x in parentheses squared plus k, where h and k are the vertex. This comes directly from what we talked about in section 2.5, where we talked about translating these graphs left, right, up, down. Remember, the number on the outside was your vertical translation. Number on the inside was your horizontal translation. So h and k, when it's in this format, you can look right at it and tell that's the vertex. The axis of symmetry is always the line x equals h, since it cuts right through the vertex, so it's going to be where the x coordinate is for the vertex. If a is positive, just like before, the graph will open up. If a is negative, the graph will open down. So in the homework, there's going to be some questions where they're going to ask you to identify the vertex, maybe identify the x-intercepts, the y-intercept, things like that, and put a lot of this together to make a sketch of it. So to make a sketch of a graph, first determine whether the parabola opens up or down, and that's going to come directly from that a value, whether it's positive or negative. Determine the vertex of the parabola by looking at that h and k. Find any x-intercepts. Remember in the last chapter we talked about with lines, to find an x-intercept we replace y with 0. Same thing, remember f of x is the same as y, so we replace that with a 0. To find the y-intercept, remember we replace x with a 0. That's going to come up quite a bit in this chapter, finding intercepts, so remember that. To get x-intercepts, you replace y with a 0. To get y-intercept, you replace x with a 0. And then plot your intercepts and your vertex and connect them to make your graph. So let's look at this example here. First thing we want to do is determine which way the parabola opens. So since the leading coefficient is negative 2, that means a is negative, which means the graph is going to open down. Step 2 was determine the vertex, so we can just look at h and k to get the vertex. H, that's your horizontal translation. Remember, that's always opposite, still applies here. So the vertex is going to be at the coordinates positive 3, 8. K does not change, but H does, so 3, 8. Step 3 was to find any x-intercepts, so I'm going to replace f of x with a 0, and I'm going to solve for x. Now this goes back to some of the techniques we talked about in chapter 1 when we talked about solving quadratic equations. One way to solve this would be to use the square root method. That's probably the easiest way to solve this. Remember, the square root method said that we want to isolate whatever it is that's being squared. Don't FOIL that out. Let's try and get it by itself first and see what happens. So to do that, I need to subtract the 8 first. So I have negative 8 equals negative 2 times x minus 3 squared. Divide both sides by negative 2, so I get 4 equals x minus 3 squared. And now I can go ahead and take the square root of both sides. Remember, when you take the square root, you have to remember to put plus minus. Don't forget that. Still applies. Plus minus 2 equals x minus 3. And sorry, I didn't leave a ton of room in the notes here, so I'm going to grab another sheet of paper here. And then we're going to go ahead and solve for x. So make sure you see what's happening here. I've got positive 2 and negative 2. So positive 2 equals x minus 3. And negative 2 equals x minus 3. So we're going to have two distinct x-intercepts here. One of them is going to occur at x equals 5. The other one, if we add 3, is going to occur at x equals 1. So those are my two x-intercepts at 5 and 1. Step 4 was to determine any y-intercepts. So I'm going to replace x with a 0 so that I can find the y-intercepts. Let me move this up so we have some space. And I'm going to write it over here. So we've got, I'm going to replace the f of x with a y. So we have y equals negative 2 times 0 minus 3 squared plus 8. To simplify this, make sure you follow order of operations, parentheses first. So that gives me negative 2 times 0 minus 3, which is negative 3, squared plus 8. Negative 3 squared is 9. So we have negative 2 times 9 plus 8. Negative 2 times 9 is negative 18 plus 8 gives me a y-intercept of negative 10. So let's put all this together on our graph. So let's start with the vertex. So the vertex, if you'll recall, was at 3, 8. So let me put some numbers on the graph. So I'm going to go over 1, 2, 3. And I'm going to count this way by 2s because I only have 1, 2, 3, 5. The graph only goes up to 5. I need to go up to 8. So I'm going to count by 2s. I'm going to label it that way so the reader knows that's what I'm doing. So this is 2, 4, 6, 8. You can scale it however you need to. Just make sure you label it accordingly. So 3, 8 is the vertex. We said it would open down. We said it had x-intercepts, if you'll recall, at positive 1. So I'll put the point there. And at positive 5, so I'll put a point there. And then the y-intercept was at negative 10. So I'm going to count down by 2s again, negative 2, 6, negative 8, and negative 10. So there's my y-intercept. And then I'm going to connect all of this to make my graph. And it should make sense that it opens down based on what we have. And there we go. So there's our parabola opening down. The second part of the guided notes for this question, it said find the domain and range. And I want to keep reemphasizing domain and range from a graph because that's a really important skill. If you look at the graph, you notice that there's no breaks in the graph, there's no holes. The arrows indicate that it keeps going forever. And also remember what we talked about in chapter 2, if there's no radical square root in the original function or there's no denominator in the original function, our domain, remember, is all real numbers. And that's going to hold in this chapter. Anytime we have a quadratic function, the domain is going to be all real numbers. Now, the range depends on which way the parabola opens. There is no lowest y value on the graph because of the arrows, but there is a highest y value on the graph, and that should be where the vertex is at 8. So my range is going to go from negative infinity up to 8 with a bracket, and that's going to be our range. Okay, let's take a look at example 2. Same thing, they want us to go through the steps to graph it. So let's go ahead and start with determining which way this opens. So the leading coefficient is 1. And so that means it's going to open, it's positive, so that means it's going to open up. Okay, step 2 was to find the vertex. So the vertex is going to be at h comma k. H, remember, is always opposite, so that's going to be at -1 comma 2. Step 3 was to get the x-intercept, so I'm going to replace the f of x with a 0. And we're going to try solving this and see what happens. Let's use that square root method again. So I'm going to subtract 2 to get the thing that's being squared by itself. And then I need to take the square root of both sides. Now, what do you notice here? Hopefully you see that we're taking the square root of a negative number. And remember, when we work with graphs, we're only dealing with real numbers. So since we can't take the square root of a negative number using real numbers, that means there's no solution to this equation, which means there is no x-intercept. And if you think about the fact that the graph opens up and where the vertex is located, that should make sense to you. And you'll see it in a second when we do the graph. The y-intercept, however, there will be a y-intercept. So let's go ahead and replace the y with a 0 and simplify it and see what we get. So 0 plus 1 squared, of course, is 1. 1 squared is 1. 1 plus 2, we get a y-intercept of 3. So let's go ahead and start putting some of this stuff together. The vertex was -1 comma positive 2. There was no x-intercept. The y-intercept, we said, was at 3. So that's all we got. Not a whole lot to go on. But remember, we said it opens up. If it opens up, the vertex is the minimum or the lowest point on the graph. So that means this is where the graph is going to stop. This is where the axis of symmetry would cut through it. So it's going to go up through the y-intercept on the right, and then it's going to do a mirror image on the other side. And like I said, that should make sense with the algebra that we got no x-intercept, because you can see it opens up and that vertex is above the x-axis, so there's not going to be any places where it touches the x-axis. How about the domain? The domain, remember, we said for these is going to be all real numbers every time, nothing to think about. The original equation had no denominators to deal with and no square roots, so we're good to go. The range, however, depends on which way the graph opens. This time it opened up, so the vertex is now a minimum. So the vertex is going to go from 2, or the range rather, is going to go from the minimum y value of 2 up to infinity. So it's going to be 2 with the bracket up to infinity, and that's going to be our range. Now, earlier in the notes, we mentioned that the general form of the equation of a quadratic function is in this ax squared plus bx plus c format, and actually this should be an equal sign here, so fix that in your notes. F of x equals ax squared plus bx plus c. When it's in that format, it's a little bit more challenging to find the vertex because we can't just look at it and say this is h and this is k. So instead we have to have a formula to help us do that, and here's the formula. The x coordinate for the vertex, we're going to figure it out by taking -b and dividing it by 2a. And then to get the y coordinate, we're going to take that number and we're going to substitute it into the function to get the corresponding y value. This looks intimidating. It's not as bad as it looks. Let's try one. So they want us to graph this function. Let's go through the steps again. Step 1, remember, is to determine which way it opens. So a this time is what? It's negative, so that means the graph is going to open down. All right, so now let's get the vertex using this new formula. So to get the vertex, the x coordinate for the vertex, I'm going to use -b divided by 2a, and make sure you see I'm doing this because it's in that form, ax squared plus bx plus c, so I don't know what h and k are this time. So I'm going to do -b, b is -4, divided by 2 times a, which was -2. So that gives me a +4 divided by a -4, which gives me -1. So that's the x coordinate for the vertex. I need to also get the y coordinate. So to get that, I'm going to substitute -1 back into the original equation. So we've got 2 times -1 squared minus 4 times -1 plus 6. Make sure you see what I'm doing. I'm trying to get the coordinates for the vertex. So I'm going to take the x value of -1 and I'm going to substitute it back into the original function to get the corresponding y value. So that gives me -2 times -1 squared, of course, is 1. So -2 times 1 is just -2. -4 times -1 is +4 plus 6. So that gives me 2 plus 6, which gives me a y value of 8. So my vertex here is going to be equal to -1, 8. Okay? And I didn't give you a lot of room here. I apologize. Let me go ahead and I'm going to get some scratch paper to complete the rest of this. So that's an example of getting the vertex using that new formula that we just talked about. So let's go ahead and get the x-intercepts. So the x-intercept, we're going to set the equation equal to 0. And I have a feeling this is not going to be the nicest number. Let's see what happens when we try to solve this. It may give us a decimal answer, and if that's the case, we're not going to worry too much about the x-intercepts. The main thing I wanted you to see was how to get the vertex. But let's see if this factors first. So I'm going to factor out, I know 2 can go into all of those, so I'm going to factor out a -2 because the coefficient's negative. That leaves me with x squared plus 2x, and then minus 3. And I actually think that might factor. That'll break down into x and x, 3 and 1, positive 3, -1. I think that works. We still have the -2 in the front. But remember, when we're solving equations like this and we're using the zero product property, the constant term does not matter. You can ignore that, but I'm going to set the other terms equal to 0. Actually, this turned out nicer than I thought. We thought we were going to get some ugly decimals, but we didn't. So we have x-intercepts at -3 and positive 1. Okay, let's go ahead and find the y-intercept. That was step 4. So remember, to get the y-intercept, we replace x with a 0. So I'm going to go back and replace all the x's with 0s. And so that gives me a y value. Notice that's 0. Oops, that's 0, that's 0. That just leaves me with 6. So I get a y-intercept of 6. So let's go ahead and see what we can do with our graph here. The vertex was at -1, 8. Again, I'm going to scale the y-axis by 2s. So we're going to put -1 here, 2, 4, 6, 8, like this. So my y, or my vertex, is going to go right there. My x-intercepts were at -3 and at positive 1. And the y-intercept we said was at 6. So we'll put that there. And remember, we said this was going to open down. So this should make sense if my vertex is here, that it's going to open down. So it's going to hit that y-intercept, or that x-intercept there, the y-intercept, and then the other x-intercept there. And that's going to be my equation. Okay. Notice it opened down, so the vertex was at the maximum again. That's our relative maximum. And so that's the next part of the notes here. It says, notice that the maximum or minimum of the vertex, or is the vertex of the parabola, depending on which way it opens. So this is going to come up a lot. If they ask you for a maximum, that means they're indicating that the parabola opens down. You just need to find the vertex. They ask you for the minimum. They're indicating that the parabola opens up. You just need to find the vertex. Okay, so this is a really key point right here. So here's an example. It says the cost in dollars for producing X hats by a company is given by this cost function. Find the vertex. So let's start with that. Notice this is in the HK format, so I don't need to use that new formula. I can go ahead and just find the vertex. So H comma K would be 40 comma 200. Would this be a maximum or a minimum? How do you know? Think about which way this opens. Look at the A value in the front. It's positive, which means it's going to open up. So what does that tell us? That we're dealing with a minimum. And so this would be a minimum because the A value was positive. Interpret this in the application. If we're talking about a cost function, what does this do? This minimizes our cost. And that was the application here, was that it minimizes our cost. If you were, think about if you're a business major and you're running a company, your goal would be to minimize the cost to your company, and this would be one thing you would possibly look at. Okay, so for the last part of the notes here, they ask us to find the vertex and the axis of symmetry for this equation. So the vertex, since it's the format ax squared plus bx plus c, we have to use that new formula that we had a few minutes ago, that negative b over 2a formula at the top of the notes. And so let's go ahead and do that. I went ahead and I worked this out already. Let me show you the work here. So x equals negative b over 2a. The b value is -2, so that becomes negative of a -2 divided by 2 times a, which is -1. So that gives you 2 divided by 2, which gives you an x-coordinate of 1. Now to get the y-coordinate, we have to substitute that back into the equation. So if we replace 1 for all the x's in the equation, we get 1 minus 2 plus 4, which gives us 3. So the vertex would be 1, 3. The axis of symmetry we haven't done a whole lot with, but the axis of symmetry is the line that cuts the graph in half right through the vertex. And so that would always be x equals, because it's always a vertical line, x equals whatever the x-coordinate for the vertex is, in this case 1. So x equals 1 is the axis of symmetry. Now the last part of the question says, without sketching it, what do you know about the x-intercepts for this function? So think about which way this graph would open. Since a was positive, it would open up, and our vertex was at the point 1, 3. So visualize that. 1, 3 would be in what quadrant? So that would be the first quadrant. And if it opens up from that point, are there going to be any x-intercepts? So I made a quick little sort of sketch here. 1, 3 in the first quadrant. If the graph opens up, there would be no x-intercepts because that vertex is a minimum in that case and it's above the x-axis. So that's what they were looking for in that question.